plans today from what I was originally going to do with you. Normally, obviously, we would practice right after an ed puzzle, but the tool that I need for us to use in order to practice with it is being used by one of the other geometry teachers today because we are right in alignment with where they are in the curriculum. So we're going to do that tomorrow, which is fun, okay? Because the two lessons kind of go hand in hand a little bit today. But yesterday, your focus was primarily just what happens when you reflect across two lines that are parallel. What happens when you reflect across two lines that are intersecting, okay? And most of you guys did a really good job with that on your ed puzzle assignment. Thank you, Mrs. Crum. And today, we're going to expand a little bit more with more compositions, okay? Because the composition means you're doing two or more transformations. Specifically, the ones we're going to focus in on today are going to be called congruence transformations, but I could have been calling them congruence transformations this entire time because rigid motions preserve distance. And they preserve angle measures. And if that is preserved, the two figures are, well, they're congruent. And the other thing I'm going to do today is I'm going to continue calling rigid motions isometries, okay, which is what I talked about in your ed puzzle as well. So I'm going to do 9.5. Homework tonight, though. The one that's due tomorrow is your 9.4 Math Excel. The 9.5 Math Excel will not be due until Monday, okay? But if you want to take care of both of them tonight, you're more than welcome to. I know some people already took care of all of the 9.4 Math Excel, and it was pretty quick, right? Yeah, okay, so you can probably take care of both. When are we testing next in this class? And that would be next Friday, okay? Next Friday will be our Chapter 9 test. After today's lesson, I really only have one more section left to teach you, and that will be the dilations, and that will happen on Monday, okay? We're going to look at our check for understanding results at the end, okay? Because I think talking about these ideas today in the lesson will help more concretely discuss the ones in your check for understandings, okay? Rigid motions. They preserve distance. They preserve angle measure. So because of that, when I have transformed an object by doing a translation, by doing a reflection, by doing a rotation, I have maintained all those things. Therefore, the two figures, the pre-image and the image, oh my God, they're congruent. That's the big idea. It's madness, right? Who would have thunk? So here what I have is I have a composition, okay? Remember what I talked about in the ed puzzle last night. We work our way from the right to the left. That is how we read a composition. We first perform the thing to the right, and then we perform the thing to the left, okay? So when I see that I'm doing something to LMNO, so this is my pre-image. The first thing that I'm doing is I am rotating 90 degrees about point P. Well, here is point P, okay? Recall, rotations. We rotate counterclockwise. Most of you did a really nice job with that yesterday or 2 days ago in your quiz. So I'm rotating this guy counterclockwise. So I can take corresponding points, and I know it's going to create a 90-degree angle, and I know the distance away from my center of rotation is congruent. Okay, so that's the first thing that I did. I rotated it at 90 degrees. Then, oh my goodness, I reflected it because that's the last thing I had to do. And it says reflected across line N. Okay, so when I reflected this guy across line N, it produced this ultimate image, GKJH. Okay, so when I have done this, when I have done my composition of rigid motions, I have produced two figures that are congruent to one another. So the big idea here is which parts are corresponding, okay? So the first question says, which angle pairs have equal measures? Oh, man. Angle L is going to be equal to which angle? Which angle is angle L going to be equal to? Very good. How do you know it's going to be G? Okay, it got flipped, it got rotated. How else could you just know by looking at the rule that G and L are mapping onto one another? How do you know that G and L are going to be having the same measurement, guys? Kerrigan?
Is it in the equation of like the combination of what you're supposed to do, like the order of how it's described?
That's what we're looking for. It's in the order that it is described. Okay, when we look at the rule, you have to have corresponding vertices in order. So L and G match onto one another. So therefore, M is going to be the same as which angle measure? M is going to be the same angle measure as Very good. And I could go on and on and on for this one, okay? L is to G, M is to H, N is to J, and O is to K. Does that idea make sense? So then, if I want to get into side lengths that are equal, if I say LM, you're going to tell me that LM has the same side length as who, Tommy?
GH.
Very good, GH. Because like Kerrigan alluded to, first two letters. Order is important, okay? So LM is equal to GH, MN is equal to HJ, NO is equal to JK, and LO is equal to GK, okay? Corresponding vertices, still important. We talked about it in 9.1. It's not going away. Does this idea make sense that these two figures are going to have equal measures? Okay. All right, your turn. Here is your composition. You're going to list all the pairs of angles and sides that have equal measure. Okay. You ready to check it? This extremely exciting, riveting dotted problem? I hope so. All right, so I'm looking for A is to X, B is to Y, C is to Z. Yes? AB is XY, BC is YZ, and AC is XZ. Yes? Awesome. Now, because we have all... Yes, Susie?
Where did the X come from?
Yeah,
And
on
then
our
she
2D
is
lines.
Z.
Oh, okay.
You guys got me. That person who was supposed to list off all the issues last year never actually gave me the piece of paper with all the issues last year. So remind me to add it onto my list of notes to change for next year. Sound good? Yeah? Okay, thank you. Okay, you good now? Alright, so because all these angle measures are equal, because all these sides are equal, oh my god, they're congruent. That's like the very beginning topic of chapter 4, okay? So like we said, they're going to be congruent. So what I can take away from this now that I'm in chapter 9 is that two figures are going to be congruent if and only if there is a sequence of one or more rigid motions that I perform to map one figure onto another, okay? So once again, examples of rigid motions, okay? We got translations, we got reflections, and we got rotations. Now the isometries that are basically rigid motions that we talked about yesterday in your Ed puzzle added on the concept of a glide reflection. Now can someone remind me from last night's Ed puzzle, what is a glide reflection? What is a glide reflection? Susie? I saw you raise your hands. I thought you were...
Yeah, I thought I was, and then I forgot.
Okay, Kiana?
Was it transformation and a reflection?
So I'm not looking for transformation, because I think transformation, an example of a transformation is a reflection. So it's not transformation we're looking for, it's... No, translation, okay? It is a translation and a reflection. Now the piece that you need to understand, though, is the translation has to be parallel to, it has to be in the same direction as the line you reflect across, okay? For example, if I translate up and then reflect across a vertical line, then I have a glide reflection. But if I translate left and reflect across a vertical line, that is not an example of a glide reflection, okay? So that's a very key concept right there, okay? So, which pairs of the figures in the grid are congruent? For each pair, what is a sequence of rigid motions that maps one figure onto the other, okay? So I clearly have 3 different types of figures. And we need to write the rule that gets me from one onto the next. Now, can we all agree that P, Q, and H, G are congruent to one another? We all agree? Okay. So now I want to know, what is the sequence? What is the rule that would take me from either PQ onto HG or HG onto PQ? What transformation do you see? Okay, so Susie says it's a translation. I can get behind that because it looks like they haven't changed their slope. So I can't conclude that it's a rotation or reflection. I'm thinking they stayed the same slope by a translation, okay? Do you think it's 1 translation or 2 translations? Even if it was 2 translations, can't you always condense it into 1? All right, so let's write a translation rule, okay? And the first set of figures. Translation, something, something. Okay, we'll fill in those blanks together. Do you want to go from PQ to HG or HG to PQ? Okay, PQ to HG. So I'm going to say I am translating PQ, and it's going to produce HG. So now the question is, how do I get PQ to land on HG? Now notice we just declared it. P has to land on H. So the question is, how did I get from P to H? What's going to fill those in for me? So over 2, does that mean
To the right.
to the right 2? So Susie says to the right 2. You agree with her so far? All right, so that goes first as a positive 2. All right, so I went to the right 2. Then what? She says down 9. Do you agree with down 9? All right, so let me see. Down 1, 2, 3, 4, 5, 6, 7, 8. I like it. Down 9. Very good. That was only 1 rigid motion, and that's totally acceptable. That is not an example of a composition. However, it's an isometry, and I know the 2 figures are congruent. Questions on how we produce those 2 things. All right? Can we all agree that this triangle, by appearance, is congruent to this triangle? We all agree. Okay? How do you want to get one of those triangles onto another one? You're going to let Susie continue carrying all this? She keeps raising her hand. She's like, girl, I got this. Phoebe?
You could reflect it over X and then move it over 2 to the right.
Okay, so which one do you want to reflect over the X?
E, D, F.
Okay, so if I reflect EDF over the X, so the X-axis is this guy right here. So this guy becomes right here. This guy becomes right here. And then E becomes, I believe, right here.
Wait, would you reflect over X equals Y? X equals -1.
Well, let's stick with this one. It's fine.
Okay.
We can try a different one because that's another thing about this particular section. There's more than one answer. All right, so far, Phoebe has reflect over the X-axis. Okay. Now we're going to do it, Susie.
Oh no, I had a question. Would this be one you could rotate?
Ah, maybe we could have just rotated from this entire time. Hold on to that thought for just a second. Let's finish it with this way. Okay, hold on to it though. So far we reflected over the X-axis. Has it landed on my image yet? What do you got to do now? Very good. Reflected over the Y-axis and it lands exactly right there. So now we need to articulate that. We just did a composition of 2 reflections, which means I have to have one rule and another rule, and then I'm going to say I did this to triangle EDF, and it produced, and that's when we're going to be really careful here, okay? Now, we'll fill that part in just a second. What did Phoebe have us do first? What did Phoebe have us do first? What was the first transformation? Alex?
Reflect over the X-axis.
Very good. We reflected over the X-axis. Because she had us do a composition, we have to put it here. reflect over the x-axis. Because remember, when you're writing a composition, you read from the right to the left. Does that make sense? Okay? So just for our references, I'm going to label here. This would have been D, this would have been F, and this would have been E. Because that's going to help me understand who maps on to who. Does that make sense? All right, so then what did we do? After we reflected across the x-axis, then what? Reflected over the y. Very good. So that was what we ended on. Y-axis. So when I did that, if I do that over the y-axis, this is going to be F, this is going to be D, and this is going to be E. So that kind of just helped me out to figure out who becomes who. So if it's triangle EDF, E landed on which vertex? Very good. D landed on which vertex? Very good. So we have M, L, then what? Very good. Okay. Now let's go back to what Susie was alluding to. Okay? In your lesson last night, you learned about reflecting across lines that intersect, correct? Well, do the x-axis and the y-axis intersect? They do. So when I highlight, this is the y-axis, this is the x-axis, these lines intersect. And they intersect at what angle? 90 degrees. Last night in your ed puzzle, you learned something. When I reflect across two lines that intersect, ultimately I'm a rotation. And what did all of you did a pretty good job on this. You all discovered it's going to be what angle measure that I rotated. It's going to be double. It's going to be double the angle measure created by those lines of reflection. So in this situation, that's 90 degrees, so I'm really just rotating what? Very good. So I could have condensed all of this into a little rotation of 180 degrees about the origin. Does that answer your question, Susie? Perfectly acceptable answer. Does that kind of make a little more sense now too? Awesome. All right, so we still have two more figures, okay? Let's now focus in on these quadrilaterals here. I believe we can all agree that they're probably going to be congruent, yes? Because we are like super rock stars at like chapter 4 and chapter 6. We probably already all can count. But I'm now in chapter 9, and I got to prove that I can make them land on top of one another using transformations. What do you want to do? How do you want to get them to land on top of one another? All right, Phoebe, what is your thought?
A reflection and a translation.
Okay, so who do you want to reflect and translate?
Reflect A, B, C, J over Y.
The y-axis? Okay.
Yeah.
All right, so notice I'm kind of playing around with it as she's going. Reflecting this over the y-axis, so this is now C, this is now B, this is now A, and this is now J. So we just did a reflection over the y-axis. So far happy with what Phoebe's done? Okay, I'm going to start to write this out, okay, because it's looking like it's turning into a composition, so I'm going to have two rules. I'm performing this onto A, B, C, J, and I got to figure out who it's going to land on. First thing that Phoebe just had us do, she had us reflect across the y-axis. Another way of saying the y-axis, please remember, is x equals 0. That is also the y-axis, okay? All right, now what?
And then translate it 1 to the right and 5 down.
Okay, so,
Oh, sorry, just kidding. 1 to the left and 5 up.
so 1 to the left. You happy with that, guys? And then 5 up. 1, 2, 3, 4, 5. All right, so 1 to the left and 5 up. So we did a translation of capital T. 1 to the left is -1. 5 up is +5. Okay? So now the only piece of this puzzle that I haven't filled in yet is who maps on to who. Okay? So we started off with A. Where's A going to land onto? Go ahead, Olivia.
W.
Very good, my dear. Where does B land? Good, Yana. Where does C land? And then lastly we have questions on this? All right, here's your got it question. Again, many correct answers. Okay, and I see some of you have already done them. It's fine. That's fine.
Is it just like a joke?
Yeah, I think so. Because the email address is not a scam at gmail.com. Says investigating whether people can distinguish between a scientific study and a kidney harvesting scam.
I like the font they used.
I agree.
Do we help with the kidney harvesting, or do our kidneys get harvested?
See, I would have to imagine you're getting your kidney harvested.
Nice.
We don't know.
Do you get another kidney?
You know what? I do not know.
I'm not really using my kidneys right now. So.
You might want them one day. One day you might want them. Plus, I would only personally donate my kidney to like a family member potentially. Like if one of my family members really needed it, consider it. All right, shall we check the answers, maybe? All right, full disclaimer. Is there more than one way to do this?
Yeah.
Okay, so if you don't see the answer I have, it's fine. These were two of the answers we came up with last year. Okay, to translate ABCD onto HIJK, we had to translate 6, -5. Does that work? Do you like that one? Maybe. You do? Okay. If you went from HIJ to ABCD, would these just flip signs? Okay. Then for triangle UVW onto GMN. Okay. So that's what they did. UVW onto GMN. They did first a translation of 6 to the left, then a reflection across the x-axis. Okay. Yes, Tommy.
I think that's a cube.
That's a Q. You're right. Good call. That's definitely a Q, not a G. All right. Other ones. I'm gonna throw this one out there on the board. Okay. Another one that somebody came up with last year. It took triangle QMN onto triangle UVW. They actually did 3 things. Okay. The first thing they did was a reflection across the y-axis. Then they did a reflection across the x-axis. Then they did a reflection across the line x = 3. Now, Because that was the way they saw it. And I can't mark it wrong because it did the right thing. Now, we know better. Reflection across the x-axis, reflection across the y-axis. That can be condensed, correct? What did we just discover that can be condensed to? Rotation of 180. Okay, does that also make sense? All right. We're basically going to do the exact same thing all over again because now I get to be like, oh my god, guys, they're not just compositions of rigid motions. These are called congruence transformations. Really no point to doing this, but you know what? It's good practice. So it's okay. So in this diagram, I know for a fact the triangle JQV is congruent to triangle EWT. I want to know congruence transformation. See, that's the only way I change this example problem. That's really all it is. That maps triangle JQV onto triangle EWT. Now that's where you have to be very careful. I specifically told you the order. I want JQV, this is our pre-image, to somehow become this guy here, our image. Okay, somehow. All right. This is where we have our brainstorming process. What would you like us to do this transformation? What are some thoughts? Susie? Okay, so we've like reflecting then translating. Okay, now let's get more specific. Because I could reflect it this way, I could reflect it over to here, I could reflect it over to there. Let's get more specific. She says a reflection then a translation. I like where it's headed. What reflection? Okay, so she says reflecting over the y-axis. Let's test it. So we can go here. That would be Q. J would be here. And then V would be here. So far you like it? Okay, Olivia?
Why are all four quadrants of the graph different from each other?
In what way?
Oh, that's weird. The lines.
The lines.
The spacing on the lines is different.
No, they're like this is there. It's just so hard to see on mine. Because if you look at your paper, it should still be there.
We
don't
can
have
have
that.
that.
Oh, how cruel of
Different
me.
letters.
Well, that's how
We also
different
don't have
We
that.
don't really have a correct
Yeah, we
graph.
don't have the problem.
Duly noted. This person really needed to give me this list last year, guys.
We'll do better.
Noted.
Blame it on the person.
Well, they signed up for this task and then they didn't fulfill their task.
Can I sign up to
Duly
that?
noted. Well, I've already taken it on most of the year, Olivia, but if you want to take it on for the rest of the year, that's fine. Okay. Duly noted for the future. We'll change the notes. Okay. Let's continue with this problem here. I like it so far. We did the reflection over the y-axis. Now what do you want to do?
I can't count the lines, but just translate it up.
Translate it up.
Up 5.
Up 5. 1, 2, 3, 4. I like it. All right, so we got reflection over the y-axis followed by a translation of up 5. Now let's write it. Okay? We're doing a composition. Okay? In our notation for composition, it's just what we've been talking about here. Okay, we're going to have something composed of something. I should probably give myself more room than I just did since I'm not going to have room to write who I'm doing this to. Okay? I'm doing this to triangle, oopsies, where's my pen? Triangle JQV, and it's going to produce triangle EWT. First thing Miss Susie had us do, she had us do a reflection. She said y-axis. Then she said to follow that up with a translation, so capital T, of up 5. Questions on our notation? All right, I have a follow-up question for you. What type of isometry is this?
Glide.
It's not just a glide. There you go. This is an example of a glide reflection. We know this is a glide reflection because the line I reflected across is vertical. The direction that I translated is vertical. They are parallel to one another, so specifically this is an example of a glide reflection. Does that make sense? All right, your turn. Do you at least have this picture in your graph?
No.
And
Darn.
different letters.
And different letters
And
again?
there's no graphs.
There's
it's
just not
base,
that.
It's just shapes.
You know what? I wonder if I would totally cut this example out.
It's verifying the
Yeah, it's
essay
on
as
your-
postulate.
I totally did. Didn't remember to cut it out of my slides. Okay. That makes sense now. Sorry, first period. Huh. All right.
We still have to do it.
What?
We still have to do it.
Of course.
Well, honestly, this is how the rest of this is going to play out. Verifying the SAS postulate. Oh my god, this is a really silly example because it's like, just to prove that these two triangles are congruent, it's like I got to do a little like reflecting rotation. I'm not even doing this example problem because it's that silly. It's like abstractly, let's just move things, okay? It's like, let's translate this triangle such that these points land on top of each other. Oh, yay, ah. See, this is where this is going. It's really not that important.
Okay, today
It's like, ooh, let's rotate it. Oh, look at that, they rotated. You see where this is going?
It's crazy.
I know, right?
How does that verify SAS?
Because then I reflected it. It's like, oh my god, it landed on top of each other. And the triangles land on top of each other. They're congruent.
That's good. It's
Where does this?
We're going to jump to this one. And this one's also silly. Are those two figures congruent to one another?
They're the
Yeah.
same size.
Oh my gosh, they're the same size. I bet you I could have just figured out by doing a simple sequence of like reflections or a translation, they'd land on top of each other. Or you could have just simply said to me, yeah, Cossack, they didn't change size. They're definitely congruent to one another, right?
Yes.
And then this last problem, it's like, oh, come on.
Wait, why did you cut out like important ones and not like the dumb?
Well, I think I cut out that one because it was kind of pointless to do another problem just like it. But I'm kind of missing that problem now, so I'm making a mental note again. This lesson I need to fix. Are those two figures congruent?
No.
Why not?
Because
Because they're not the same size. And what kind of transformation is that? Dilation.
dilation.
I wouldn't mind if you put a couple of those on the test.
Dilations?
No, I just mean like those.
Those ones?
Like
Yeah.
a real easy one.
Maybe actually.
You mean you want me to put something silly like this?
Yeah.
Yes.
Alright. You got 2 assignments on Schoology. First do the check, then do the vocab support, okay?
Then go over the
We kind of did subtly just now through the lesson, but we can look at it, yeah. The only question I really want to talk about with your check for understanding is the basketball problem.
That's the only one I got right.
Well, that's unfortunately the common miss one. I'm serious. So you're reflecting over 2 lines that are parallel, which means ultimately it's just a translation of double the distance, okay? So you're really looking for your pre-image and your image to be the exact same orientation, so like we know the answer is not C, okay? And then the other piece you just got to remember is when you reflect across a line, your points that are corresponding are perpendicular to the line of reflection as well as equidistant. So like if I'm looking at this middle line and this guy here, those are so not equidistant, so not perpendicular, right? You agree with me? So then when I look at B, did I even do a reflection from this guy to this guy? No. So it only leaves me with D. Okay? Because if you match up the points, yeah. Because if you match up the points here, these would be perpendicular and equidistant from this spot here. Okay? Make sense? All right. There we go. Man. All right, let's see. Let's stop this. 9.5 video. 4:19:18.